Welcome everyone. Today's class. This is also the practical class. Okay. Now today we want to discuss at first the qualitative inorganic analysis. The title you can show you in the board, that qualitative analysis of unknown inorganic sample marked as IX. This is just the title, as it you have to write in your copy or also in the question paper. Now the first is that what is qualitative inorganic analysis. So at first the today's part is basically depends on the theory, that about the detailed analysis of that the experiments you have to perform regarding to that analysis. At first I will give you the introduction to this. Okay, so today's part basically depends on theory. Theory means related to the practical. So this is qualitative inorganic analysis or qualitative analysis of inorganic salt. Okay, so today it is basically that analysis part. First I will discuss in the board about that topic, then I will go for the observation part, that is what you have to perform or etc. Okay, so at first I will discuss it in the board, just observe it. Now I am submitting a topic, a PDF in your group. This is about the qualitative analysis. Everyone download it and open it. It will be easier for you for that overall part. Okay. Clear? Now everyone download it, and as I will mention the page number, you will look on that page number. So at first just an introduction. Suppose AB is a water soluble sample. Okay, AB when it is in aqueous medium, it will dissociate to form A plus and B minus. Both of them are solvated. Both of them are solvated. So you can see that part of that salt was bisected, that is cation part and the anion part is produced and they are solvated. So now they respond to some test. They respond to some test that we have to perform. Now A plus, this is the cationic part or this is the basic part, and B part, that is anionic part or acidic part. Okay, so this is basic radical and this is acidic radical. Now we can represent AB as any one sample. I will later on discuss about that matter. Okay, now we will come to that what we have to do, that is qualitative analysis. This is basically divided into part. One is for the cation, test for cation, and another part is for the test of anions. Okay, so cation can be responded by two types of experiment. One is the dry test, next is wet test. The another name of wet test for cation is called group separation. Anion can also responded by dry test and also wet test. So four kinds of test is there. Though when we will do this, we will just make an assemble of all these experiments and we will select some of these that we have to write in your copy and also during that analysis. So this is basically the four kinds of test is there: dry test and wet test for acid and base. Now what is the importance of dry test? Now dry test, the importance of dry test is there that it give you a preliminary idea. The dry test, when you will look at the observation and inference of the dry test, you can see it is a maybe type experiment, that is nitrate may be present or sulfide may be present, nitrite may be present, chloride may be present. This type of experiment, or in case of basic radical, suppose iron may be present. So this type of may be present type conclusion is basically coming out from dye test. Now the wet test give you that confirmative idea. Wet test give you the confirmative idea regarding the presence or absence of a particular cation or anion. Okay, dry test and wet test. Telling about dry test and wet test. Now we will go for example of cation and anion. Examples. Now the example of cation. These cations are divided into groups. These cations are divided into groups depending on their solubility product. And these groups are, they are having 0 group, 0, 2 and 1 to 6. 0 including 1 to 6. And each of these group contains some selective cation. These are basically, they are classified according to their similar types of test and also the types of solubility product. One is test, another one is solubility product. Depending on these, they are classified. So in group 0, the cation present is NH4 plus. When you will write the cation name or anion name, then you have to write that the cation or anion. Suppose copper ion, nitrate ion, not that copper, the elemental copper is not here. In 0 group, this is only NH4 plus. In 1 is lead, mercury, etc. In group 2, okay, in group 2 also the lead, mercury, with that the arsenic, antimony, these are there, but we will not consider that one. Now group 3, here the important is aluminium and iron. Group 4 is that zinc. In group 2 they are having copper. Then group 4 zinc, cobalt, nickel, manganese. All are important with our respect. Other cations are also there in this group, but we will write only that is basically important for us. Group 5 having barium, calcium, strontium. All are in +2 state. Cobalt 2 plus, zinc 2 plus, nickel 2 plus, Mn 2 plus, iron 3 plus or 2 plus, aluminium 3 plus, copper 2 plus, Hg 2 plus, lead 2 plus, it is +1. Next group 6, it having Mg2 plus and group 0. So this is the separation of cations into groups according to their reaction and their solubility product. Okay. Now some example of anion. Example of some anion I am writing here. Anions. So first of all, halides, that is chloride, bromide, iodide. Then it is the nitrite, NO2 minus, NO3 minus, etc. After that, sulfide, SO3 2 minus, SO4 2 minus, acetate, oxalate. These are some common anion which is attached with that basic radical. Now you can see here how many combinations can be formed. A lot of combination can be formed, but we will select those sample like that are water soluble. Okay, so this is the separation of groups into cation, and these are some common anion. The anions are not classified according to that group. The cations are classified, which is very important. Okay, up to that it is clear. Now this separation you can see on page number. This type of separation you can see on page number. Just move to that page number of that PDF. As I am saying, it will be the detailed discussion. Okay, move to page number 69. Move to page number 69. You can see there the separation of cations into groups. In group 6 it is magnesium. In group 6 it is only cation, that is magnesium. Okay, now I am telling where it is discussed. Okay, move to page number 71. Move to page number 71 quickly. Move to page number 71. Move to page number 71 where you can see this group separation table with that group reagent is there. Now the group reagent, what is group reagent? By adding that particular reagent, the precipitates come. Okay, now here something to tell about. Now suppose your sample contains zinc, then you directly cannot move to zinc. You have to go by that process. That is, first add the reagent of group 0. If absent, then go for group 1. If absent, then go for group 2. If absent, then go for group 3 and then come to group 4. If group 6 cation is present in your sample, then also you cannot directly move because you don't know about the presence of that particular ion. So for this, it is called systematic group analysis. You have to go one by one. That is, after group first 0, then 1, 2, 3, 4, and at the same time you have to show the absence of that group. This is very important. You have to show the absence. Suppose you are writing that systematic analysis for basic radical, then you jump to group 6, but you omitted the other groups, then it will be the reduction of marks. It is not the correct representation. So for this, be aware about this. And the PDF submitted, that is uploaded on this group, just if you move at the bottom, at the last 2 pages, it is one of the sample is given that how to write down this. At the bottom of this, there is a unknown sample treatment is given. Suppose this is for magnesium sulfate, so it will also help you to understand this. Okay, now I will go for that tabular format that you have to write when you will write in the copy. So now move to the bottom of that page. You can see that it is the magnesium salt is given. Look at the analysis, how it is done. That is in page number 84. Look at the observation in 84. 84 and 85. It is magnesium sulfate is there. Okay. Clear? Now I am going to that test. So you can see there at first the preliminary idea about the sample is given. So the preliminary idea, that is physical characteristics. Under this title, the first point you will write physical characteristics. Physical characteristics, that is the color at first. Next is that the crystal, about the crystal, as it is crystalline or amorphous. Obviously it will be crystalline or amorphous. Obviously the crystalline you will write. Next is that solubility. Solubility, all the samples will be water soluble. All the samples will be water soluble. And one PDF I will submit on this group later on, that will contains the direct test of the cation. Direct test for cation. But the part I am discussing in this, that is overall idea, because to gain overall idea it is required. So physical characteristics is over. Now divide it into 3 columns. As you can see, experiment, observation and inference or conclusion. Okay. Now just remember that 4 kinds of experiment, that is the dry test, acid basic, wet test, acid basic. Okay, so I will write down only the experiment name here, only the experiment name and the respective conclusion, that you can see it in that PDF. I will also mention the page number just for one. Okay, so first experiment, it basically from the dry test of acid radical, that is dilute H2SO4 test. Now what to do in this? Take sample in dry test tube plus dilute H2SO4 plus heat. Okay, this is the procedure. Take dry test tube, sample plus dilute H2SO4 plus heat. Now what kind of observation may be there? It is generally the gas is evolved from this. Here this experiment, the gas is evolved. This gas may be from carbonate, this may be from any nitrite sample or etc. Now I will telling one page number in that particular PDF where you can see that what is the importance of this test. As I told earlier that this dry test is give you a preliminary idea, not that confirmative. So in inference you have to write these cations or these anions may be present here. Okay, so now okay, now move to page number 51. Move to page number 51 of that PDF. Step 1, preliminary test with dilute sulfuric acid. Everyone is there? 51. Find it. Respond. Page number 51. Have you got it? Okay. Now look at that chart. Look at the chart. That what is the importance? You can see that observation, inference, that is gas evolve. Possible anion may be present. Okay. So this is the possibilities that these observation give you a particular inference. But when, if no gas is evolved, then you have to write that carbonate, sulfite, nitrate, these are absent. In that way you have to go. Just listen to me that if you do that test and you so there is no such observation, that is no gas is evolved in that section, then in inference section you will write the carbonate, sulfite and nitrate, these are absent. So in that way you have to go for all these experiments, and when you look downward in the same page, that is from 61, that will be the detailed analysis of individual experiment. Okay, next is that concentrate sulfuric acid test. Here sample in dry test tube, add concentrate sulfuric acid, look that any gas is evolving or not. Okay, so here also some inferences is there, but this is also under dry test. After that it is called brown fume test or concentrate H2SO4 plus copper turning. It is the fumes of nitrate comes out by this when you will heat it. This is plus heat. Number 4 is that dilute H2SO4, concentrate H2SO4 plus copper turning. Okay, next is that for test tube heating. The test tube heating test may give you some responses, that is any gas may form. Direct test tube heating, that is you have to take the dry test tube, take the dry sample, directly heat it on the Bunsen burner. So gas may be evolved, or any color may be changed, or supplement may form, but not that it will happen. It is a probable. The gas may evolve, color of the sample may change, supplement may form. So for every observation there is a specific inference. You will see it. This is under the dry test of basic radical. This is under the dry test of acid radical. When you will observe the unknown part, that there no experiment is mentioned. So in this experiment column you will mention that experiment, that title. It will indicate no elaboration is required. Just indicate that concentrate sulfuric acid test. Okay, test tube heating test. Number 5 is that flame test. Flame test is performed by using platinum wire. Here the volatile chlorides is formed when the tip of that platinum wire with sample is touched with concentrate H2SO4 HCl, and when it comes to the flame it gives different color. Basically all these cations are basically responded. Some of these are very much active in this sense, very much important, because the color change is very prominent here. That is, for example, strontium, barium and calcium. So if these cations are present, copper, if these cations are present, then you have to write this flame test and you have to present it. That is, that particular flame is formed and it is maybe due to that barium or strontium or calcium, etc. If these cations are absent, then no such flame is observed, these cations are absent. Next is that after flame test, it is the charcoal cavity test. Charcoal cavity test. All these tests you have to mention in your column. It is not that this cation is absent or this anion is absent, so I will omit that test. Don't do that. You will write all these experiment, but you have to change in this observation and inference area. If absent, then write down that this particular observation is not found and these anions or cations are absent. Charcoal cavity test. After that charcoal cavity, there is a special test that is called as borax bead test. Borax bead, but this is only for color sample. This is only for color sample. Suppose you have given copper sulfate or you have given nickel sulfate. These are colored. Okay, iron sulfate. These are also colored. So you have to write this and you have to write here that observation is found here. You will got it on this PDF. Go to the borax bead portion and look at that observation. Okay. After that, you will got another test, that is Kmno4 test. Kmno4 test. This is number 8. Kmno4 test. What is this test? Now Kmno4, this is the decolorizing the color of Kmno4. That is, if iron is present, it will decolorize the Kmno4 color. If acidic substance is present in your sample, it will decolorize the Kmno4. This is also the preliminary idea. So the number 8 is Kmno4 test. Now tell me, what is your problem regarding that explain. Letter 5, 4 to 8, these are the preliminary test for basic radical. Now tell me, what is your query regarding that? That is about charcoal cavity test. Okay, the charcoal cavity test is under the dry test of basic radical. Now some cations respond by this, that is, one of them is aluminium. Okay, so if you got aluminium, then you have to present it on this section. So what you have to form, this is having a charcoal block is there. Okay, you have to make a group on this charcoal block. Now add a sample here. Just add 1 drop or 2 drops of water above the sample. Now use the flow pipe. Use the flow pipe to heat it. Then it will reduce. It will reduce and it will give a color. This color is important to us. Okay. So this is about the charcoal cavity test, or it is also called as cobalt nitrate test. When you will add 1 drop of cobalt nitrate on this hot sample after heating, it will just turn to a bluish color. This is to indicate that the aluminium is present here. Now for this, you look at that experiment, the charcoal cavity test, in this given PDF. Okay, no one having any doubts regarding to that? Now I can move further. Now this test you have to write, but you need not to perform in the laboratory, because we will follow that direct test to presence of the cation and anion. direct test is there, which will come later on. After what I will discuss, it will be the important with your respect. Okay. Now I am rubbing the portion. Okay. Next is that number 9 is that conformative test for anion. Conformative test for anions. Now we will give emphasis basically on these three: Cl minus, NO3 minus, and sulfate. Okay. So now is the context of preparation of OS, because the dry test is basically the solid sample is taken. For this it is called also dry test or preliminary test. But when we will go for the conformative test, we have to prepare the solution. So before going to that, preparation of OS is there. Preparation of OS, as I told you, all the samples are water soluble. So sample plus water, that is forming the aqueous solution or OS, original solution. Now taking the original solution OS all the time, we will do that test. Now first is that under this number 1 test for Cl minus, OS plus KgNO3 if white PPT, Cl minus confirm. If white PPT does not appear, then the Cl minus is absent. Now it is a further proof of this AgNO3, that this white PPT remains dissolved in NH4OH. If the white PPT comes, just to further confirm it, add NH4OH solution, it will dissolve that. If white PPT, then white that Cl minus confirm. OS plus barium chloride solution, white PPT. If white PPT insoluble in mineral acid, that is called sulfate present, SO4 minus confirm. After that, OS plus ferrous sulfate solution plus concentrate HNO3, this is called as ring test. Okay, ferrous sulfate solution and then ring test. If a brown ring form, then it is the nitrate. If no ring is formed, then it is absent. Nitrate present and confirm. Basically these three anions is important with your respect, because all the samples will be selected that must contain either of these, anyone, either chloride, either sulfate, or either nitrate. Okay, so this test you have to perform. So first prepare the OS, then add one by one that solution. This is called direct test and also the conformative test. We will confirm by doing that test, and we have to arrange it, that how to represent it in the tabular form. Suppose chloride is present here. Suppose you got chloride here, then you have to think that in dry test where we have to present chloride. So where there is a reference is called that it is the that for chloride, then you have to present on that section. If you find that nitrate is present, you have to present on that dry section where the specific test is there for nitrate. that is the in copper turning test, it will give us a brown film. So in that way you have to represent it. Okay. Next is that we will go for, up to this completed everyone. Okay. Now we will go for question number 10 experiment, that is called systematic qualitative analysis. So these three under the weight test of basic acid radical. Okay. So other anions are also there, like acetate is there, oxalato is there, and the other anion, bromide, iodide, these are also there, acetate is there, but we generally use that because of it may produce some problem, because so many composition then arise. So for this it is generally omitted. Now is that we are the number 10, that is conformative test for cation. This is in the experiment section, observation and inference. This chart, as we have started at the beginning, it will continue to the end. Just look at that sample. Conformative test of cation within bracket systematic group analysis. Systematic group analysis. Okay. Now if you observe carefully that chart, that also having a group reagent. Now this group reagent give a PPT. Okay, suppose a sample, the aqueous solution plus group reagent. Group reagent gives that PPT, which will be deposited at the bottom. So it will give a PPT. It might be white, it may be colored, etc. Now this PPT you have to filter. You have to filter, and taking the residue in the filter paper, you have to dissolve this residue. You have to dissolve the residue and then go for test. This is the actual format, that what we have to do. Sample, when you will add group reagent, it will give you the PPT, filter it, then taking the residue, dissolve it in a particular solvent. It might be dilute HCl, concentrate HCl, NH3, etc. Dissolve it, then go for that test. But we will not follow it. We will go for the direct one. Okay, it will be easier for us. Okay, now look at here. So that I am mentioning here, that is the systematic analysis you have to write. So I am giving that example regarding to a cation that are present in group 6. Okay. So first one, that OS plus dilute HCl. This is the group reagent for group 1. Okay, at first, before going to first one, just confirm that NH4 is present, that is 0 group. That OS plus NaOH solution plus heat. If the smell of ammonia comes, then group 0 is present. No smell, 0 absent. No smell, 0 group absent. If smell comes, then there is a further test, that is you have to add Nestler reagent here. Nestler reagent. It will give you a brown PPT. I will show you in experiment. Brown PPT. That is, that time NH4 will be present. So just listen to it. But as no smell of ammonia, that is confirmed by the primary experiment, so from where we can tell that NH4 is absent here. Okay, now we will go for group 2. Group 1, What is the group reagent for group 1? Just observe there. The group reagent for group 1 is OS plus, these are, you have to write on the experiment column. These are experiment column. OS plus dilute HCl. As we are considering group 6, so here it will be no PPT. Group 1 absent. Next, OS plus dilute HCl plus heat plus H2S gas. No PPT. The inference will be group 2 absent. OS plus, that is for group 3, OS plus NH4Cl plus NH4OH, ammonium hydroxide, no PPT, group 3 absent. Next is group 4, OS plus NH4Cl plus NH4OH plus H2S, no PPT, group 4 absent. Clear? In that way you will continue. Next is that OS plus, next is group 5. The group reagent is NH4Cl plus NH4OH plus ammonium carbonate. Now you can see here that the common ion effect is implied. NH4 here, here. No PPT, group 5 absent. OS plus NH4Cl plus NH4OH plus disodium hydrogen phosphate, Na2H HPO4 or metaphosphate. Here white PPT, group 6 present. That is only magnesium as it is, so magnesium is present. Now you can understand, no problem is there, board is also clear. Okay, so in that way you will write. Now just I am giving one example. If your cation present in group 5, then in that way you have to follow up to group 5. You will got PPT here, and taking this PPT you have to test for it. Suppose you have got barium. Now this PPT you have to dissolve in any particular solvent. Now look at there. Now I am telling you to move on that page where this analysis is given. Suppose one group 5 cation is present. Okay, now come to page number 79. Come to page number 79. Page number 79. Got it? Page number 79 of that PDF. Find it. Respond. Page number 79. Look at this. If group 4 is present, then take the original solution. What is given? NH4Cl, NH4OH and ammonium carbonate. Okay. Now dissolve the white PPT boiling with dilute acetic acid. Okay. If group 4 you got, group 5 you got, then you have to write from this section that from dissolve to that particular cation, presenting the particular cation and rejecting the other two, because here having three cations present, barium, strontium, calcium. So you will got only barium. So the test you will confirm on the barium section. Okay. So in that way, in this experiment column, after group 5 you got the BBT. Now dissolve the BBT in dilute acetic acid, and then we will add potassium chromate solution. This you have to write, but we will do that is different. I will show you. Okay, no tension is there. You have to think about that how to write. You have to manipulate your brain that how to write it. Okay. So if barium is present, now look at the left column, it is for barium. So you have to write these two experiment on experiment column. After group 5, this is present, then you have to write this experiment on the experiment column, make confirm this barium, and other obviously will be absent. Okay, if barium is absent, it is given. Suppose you got calcium, then you have to write that barium is absent, strontium is absent, then you have to go for calcium. As from left column to right column you will move. Okay, so I think it is clear to everyone that how to write this part. And when you will write that two experiment, or you will confirm that one, so after that the table is completed. Then at last you will write the conclusion that the supplied sample contains this cation. Now the name is important very much. Okay, just look at here. Suppose you have got magnesium, then how to write it? So that you will write the statement, the given sample contains cation. Cation is magnesium ion, in words magnesium ion, within bracket the formula Mg2 plus, and sulfate ion SO4 2 minus. 2 marks is allotted for this one, this representation. So if you write only that magnesium without that formula, or only sulfate without that this formula, then you will got only half marks. Okay, there is the state marking is there, so you have to be careful on this. Now I will show you some analysis of sample. So for this we have to move to the opposite side. Now look at there that how to perform this. Okay, any doubts regarding the total process? Now I will observe that part, that experiment how to do it. Okay, no one having any doubts? Okay, okay, so first I am taking a sample, an unknown sample. Suppose this is aluminium sulfate. I am just doing it, taking any known sample. Aluminium sulfate we have taken. Okay, so first what I have to do, as I told, this is the solid aluminium sulfate. take the sample in the test tube. Take the sample. You can see this is the solid sample taken. Now add water to make it solution. This is the first work for you. Take the solid sample which is supplied. Now shake it well to dissolve it. Now you can write the unknown sample. You will try for this. Okay, now this is called OS, as we have done before the confirmative test. Now keep it reserved. Take another one test tube. Just take a little sample. Just this amount of sample is sufficient for a test. Okay, just this little amount, 2 or 3 ml. The test tube is of 20 ml. Now what is the test? Though you don't know about this, so the test is that at first you have to add NH4Cl. So the NH4Cl, you can see this is NH4Cl solution. It will be available on every rack. Added NH4Cl. Now next to that you have to add NH4OH. This is NH4OH. Add with this. This is called floating PPT test. Floating PPT test. Now add, you can see the PPT already comes, a light colored PPT. Now further to prove this, so dissolve this PPT in HCl. Okay. You must have to use apron. So for this, you will collect the apron previously. Okay, you can see that PPT dissolved, totally dissolved. Now you have to add blue litmus because in basic medium it is responded. So add blue litmus, it will transfer to red color because the medium is acidic now. Red color, a light red color is there. Now add NH4OH again. NH4OH again. At the same time, it will bring the PPT and also decreases the pH. Now observe this. Very good test. This is called floating PPT test. Just observe this. This is that blue PPT which is floating above the lower half. This is transparent. Okay, this is the test for aluminium. So what we have done, first make OS, then add NH4Cl, then NH4OH, PPT will come which will float. But this is not the proof that it is only for aluminium. Then dissolve the PPT in HCl. Okay, after that add blue litmus, then again add NH4OH. When you will add dilute HCl, the PPT will dissolve. And when you will add NH4OH again, the PPT will reappear and changing the color of the solution. Now we will go for the test for anion. So the test for anion is that first we have to go for the chloride. So the reagent for chloride is silver nitrate. It is available in that particular color of bottle. Okay, this is silver nitrate. If chloride is present, it gives a white PPT. Observe any PPT is coming or not. Okay, no PPT is there. You need not to add much more chemicals. Just add a drop or 2 drops of chemical. Then it will respond if present. So chloride is absent. Next is that the test for sulfate we have to check. Now taking the OS again in a very little amount. Now the reagent for sulfate is barium chloride. I am discussing all these are from conformative section. So this is barium chloride. This is also transparent liquid. Barium chloride is available on rack. Add it. If sulfate present, white PPT will appear. Okay, look at this. A white PPT is there. Now I told you that you have to be confirmed about that. Now add any dilute mineral acid, that is HCl or H2SO4. It is available here. So this is dilute HCl. Now I am adding it to check that it is dissolving or not. You can see that it is only the increase in the volume, but PPT is not dissolved. So these two tests confirm you that your sample contains aluminium sulfate. Okay, you need not to perform the other. Now you have to write it. Clear? Now you can write this. For aluminium sulfate, the unknown treatment of an salt. Now another one salt I will show you today. Okay, this contains ammonium chloride. Now anyone having doubts regarding to that experiment I shown just now, this can be asked me. Anyone? Tapos, Rijita, Tamima, regarding the experiment for aluminium sulfate. Next I am going for ammonium chloride by an known sample. So ammonium chloride, it is already in liquid form. I am taking it from here. Now taking this is just works as a OS. Okay, this is just works as OS. Now kept it reserved. In another test tube, I will take a little amount of ammonium chloride. Now add NaOH bead to it. Sodium hydroxide bead. NaOH pellet. Just add one NaOH pellet to it, the solid sodium hydroxide. This is in the solid form. If ammonia is present, it will evolve the ammonia. If ammonia is present, the smell of ammonia will come. As we have taken the known sample, obviously it will give the smell of ammonia. Just dissolve it well and take your nose to the mouth of that test tube. Till now it is not coming. Just check it. You can observe that here a supplement is formed. Supplement is formed here. This is also to prove that ammonia is present here. Sublimation of ammonia is formed and the test tube becomes hot enough. Now we have to add here Nessler reagent. Because the fume of ammonia is coming out. Now add Nessler reagent. Okay, you can see that brown PPT. Okay, the brown PPT confirms that ammonia is present. It is a complex formed by the Nessler reagent with that ammonia. These all you will find in your inorganic portion in group 15. The reactions of ammonia you will find that type of test, that is with Nessler reagent or etc. So already we have confirmed one such cation, that is ammonia. So if you got ammonia, it becomes easier for you that in systematic qualitative analysis at first you will got it and write it. The next procedure is not required on that aspect. Next is that we have to go for the anion. That anion we will again add like AgNO3 if present. Okay, so just adding AgNO3 from this bottle. If chlorine is present, white PPT will appear. Okay, look at this. A cardi white PPT comes. Okay. Now to further prove it, we have to add ammonia solution. That is NH4OH solution we have to add. Dramatically it is dissolved. Totally disappear. This is a magical test. Okay. So this is to prove that it contains chlorine. Okay. And it is also an endothermic reaction because the test tubes become cold. Basically all the reactions are exothermic, but this one seems to be endothermic. Okay, so we have shown the experiment today. One is for ammonium chloride, another one is for aluminium sulfate. Okay, so now this is your part that you have to write it in your copy. That is taking the one sample is already given here, no problem, you can copy it from here. Next, you have to write one is aluminium sulfate or any combination you can take. Okay, now any queries are there? So one, that is anyone you can choose, threaded or binded. It will be better for binded copy if you having it, otherwise threaded copy also.